Hi class, this is lesson 7.1. For those of you who may be watching a video like this and taking notes for the first time, I just wanted to give you a couple pointers. Remember, you do have the pause button and a rewind button, so if I move a little bit fast, you could rewind and listen again, or you could pause the video to catch up. Some students like to listen to what I say and then pause the video and fill in what I've written, so you'll just have to learn what works best for you. So again, this is lesson 7.1. This is graph exponential growth functions. Key here, we're talking about exponential growth. This is something that you did do in Algebra 1B, so it should look pretty familiar. Our big question here is, what does the graph of an exponential growth function look like? And that's mostly what we're going to be looking at in this video. This is a page right out of your book. It's on page 478, so you don't need to write this down because, as I said, it is in your book. So we're first going to talk about the parent function for exponential growth functions. All functions that we'll study do have a parent function. The parent function is the most basic one that you can find. For the exponential growth, it's f of x equals b to the x, where b is greater than 1. The key thing here is b must be greater than 1 in order for this to be exponential growth. If you think about it, anytime you multiply something by a number greater than 1, it makes it bigger. If you multiply something by a number between 0 and 1, it'll be smaller, and that'll be exponential decay, which we'll study tomorrow. So f of x equals b to the x, that's our parent function. A couple key words here, asymptote. The x-axis is going to be our asymptote for these graphs, and you look here, your graph is going to approach the x-axis, but it is never ever going to cross it, or never go below it, and never touch it. Our graph, in order to be growth, has to rise from the left to the right, so this makes it exponential growth. And notice it goes through the point 0, 1 for my parent function, and then it also goes through the point 1b. The domain of this function is going to be all real numbers, and that'll be our domain for all of these graphs that we're going to be doing for the exponential growth. Our range for our parent function is y is greater than 0, and that'll be our range for most but not all. So let's try some together. Before we actually try, and we do need to fill a couple things in on your frame, so take out your notes at this point and look at your frame. So exponential growth is about, you need to fill in your is about statement. It's about exponential functions of the form, here's the key thing, y equals a times b to the x, where a is not equal to 0, and the base b is a positive number greater than 1. B is what we call our growth factor, so you might want to put a little note on your frame. B is our growth factor. Let's fill in our so what statement right now down at the bottom while we're on this frame, because I want you to understand a couple of important things and keep that in mind as we're graphing. Our domain here is always going to be all real numbers. That's one thing to remember here. And the point 0a, that's going to be your y-intercept. And then we're also going to have an asymptote of y equals 0. Now these two things that I just said right here, these are only when we don't have a vertical change, when we don't shift our graph left or right, up or down. So for these four on this page, we're not going to shift our graph left or right, up or down. So those two, that's only without, and you can write this a little smaller, I can't really fit it in the box writing the way I am, that's only without a shift. It does change if we have a shift of our graph, and we'll talk about that as we move on here. At the first graph, we want to graph y equals 5 to the x power. So my intercept here is going to be 0a. So remember, y equals a times b to the x power. That's my general form here. And I could put a 1 right here. So it's 1 times 5 to the x. So my y-intercept is the point 0, 1. My domain, as I said, is going to be all real numbers. My range, well, I don't have a movement here at all, so my range is going to be all real numbers greater than 0. And my asymptote is still going to be y equal to 0. Now, because this is just a general graph, I have my a value being 1. For transformation, there's none. We don't have any transformation here. So let's put our y-intercept on the graph. It's right here. And let's also put our asymptote on the graph. You always need to put your asymptote on the graph. You will lose points on any quizzes or tests if you don't do that. The way we're going to graph these is using a table. So I'm going to make my table of values right here in the middle. We're going to use x and y. And I'm pretty much always going to use the same numbers, -2, -1, 0, 1, and 2. And at this point, you should know how to complete a table, so I'm not going to take the time to go through that. I'm just going to give you the numbers. Remember, all you would do is put 5 to the -2nd power in your calculator. If you do that, you get 1 over 25. So -2, 1 over 25 would be right down here on my graph. If you put -1 in, you get 1/5. So -1, 1/5 is right here on the graph. And again, if you're not sure how to plug x values into an equation and solve for your y value, that's something you definitely want to ask me about. You could stop in and see me after school or before school or during class when we're asking questions. Make sure that you understand how to do it. We know 0, 1 is an ordered pair on here. 1, 5, if I plug 1 in, I get 5, so I've got the point 1, 5, which is right here. And then if you plug 2 in, it's 2, 25. And that's going to be way off my graph, so I'm not even going to try to graph that. So I'm just going to try and draw my nice, smooth, exponential curve in here. Do the best that I possibly can. And it's going to come close to y equals 0, but it won't cross it and it won't touch it. So there's my graph for the equation y equals 5 raised to the x power. Let's here. Okay, for this problem, we're going to graph y equals 3 times 2 to the x power. So our y-intercept, remember, we find by looking at a, so y equals a times b to the x, that's our general form, and in this, 3 is what we plugged in for a. So 0, 3 is my y-intercept, and I can put that right on my graph right away. My domain is still going to be all real numbers. Remember, that was our so what statement. Your domain's all your real numbers. My range for this is going to be all my real numbers greater than 0, because my y-intercept is above the x-axis still. My asymptote is still going to be the line y equals 0, and I'll draw my asymptote right on my graph right away, so I don't forget that. Now your transformation, what you've got to look at here is think about our parent function. For our parent function, the graph goes right here through the point 0, 1. Now, the way we tell what kind of transformation here is you look at your y-intercept, and if you look, it's kind of like that's been pulled up or stretched up here to 3. So the transformation is a stretch, a vertical stretch of 3. You might even want to include the word vertical. So vertical stretch of 3. And we found that by looking just at our y-intercept. It makes it pretty quick and easy to find. So let's make our tables now. X, y. I'm still going to use the points -2, -1, 0, 1, and 2 as my x values. And I already went in and plugged those in to my calculator, or actually did a lot of them in my head, because a lot of this you can do right in your head. You don't even need a calculator for. Plugging these in, I got 3/4 for -2. So if I plot the point, -2, 3/4, it's right about here. For -1, I got the point 3/2. So -1, 3/2 is right about here. 0, 3. We knew just by looking at the equation, that's your y-intercept. If you plug 1 in, you get 1/6. And 1/6 is off my graph, so I know I don't need to go any further, but if I did, I would get 2/12. So now I'm just going to connect my points, draw my nice exponential growth curve. It rises from the left to the right just like it should. And there's my graph. Let's look at our next example. Okay, for this example, we're going to graph y equals -4 times 2 to the x power. So our general form again is y equals a times b to the x power. Now this a value is -4. It's negative. And what that negative does is it kind of flips your equation over the x-axis. So we know that a is going to be our y-intercept. So a is 0, -4. So 0, -4 would be way down here on my graph. And that's going to be my y-intercept. My domain is still all real numbers. We've said that's always going to be our domain. Now our range here, because my graph has been flipped, my range is going to be all real numbers less than 0 this time. So all real numbers less than 0 are what I'm going to see on my graph, and my asymptote is still going to be y equals 0 though. So I'm going to draw my asymptote right in here. So there's my asymptote. And let's look for our transformation. So let's think back. Our parent function comes right through here. And I had a stretch of 4, but then it came and got flipped all the way down here. That's what that negative sign did. It made it flip or reflect over the x-axis. So for my transformation, I need to include both of those things. It's a stretch of 4 and a reflection over the x-axis. So I'm including the fact that it's a reflection and a stretch. Let's now make our table and complete our graph. I'm still going to use the exact same ordered pairs I've been using all along. So I use -2, -1, 0, 1, and 2. And just like before, I already know what these numbers are. And if you pause the video and plug it into your calculator and try and complete this on your own, that would be great practice for you to make sure you know how to do it if you're not quite sure about that. If you plug -2 in to -4 times 2 to the x, you'll get -1. So -2, -1 is right here, and that's below my x-axis as I expected it would be. If I plug -1 in, you get -2, so -1, -2 is right here. We know 0, -4 is our y-intercept. If you plug 1 in, you get -8. So 1, -8, and that is definitely off my graph. So I'm just going to draw my exponential curve for these 3 points that I can have on my graph that fit there. And there's my nice exponential growth curve. Let's now look at the next problem. Now we're going to graph y equals 1/2 times 3 to the x power. So our y-intercept, still we're looking at that a value, and my a here is right there. So my y-intercept is 0, 1/2. So 0, 1/2 would be right about here. My domain, as I've already said, is still going to be all real numbers. Now this one wasn't reflected over my x-axis, so my range is still all real numbers greater than 0. And my asymptote is still y equals 0. And I'll draw my asymptote right in here. There's y equals 0. Let's look at what kind of transformation it is. So my parent function went right here through the point 0, 1. And now my new one kind of got shrank down here. Shrank of 1/2. So our transformation, we're going to call this a shrink. of 1/2. And 1/2, you notice, is your A value, so that's why it's a shrink. Anytime you multiply something by 1/2, it's obviously going to get smaller. Let's now make our table of values using the exact same values we've been using all along. -2, -1, 0, 1, and 2. So if you plug -2 into the equation, you'll get 1/18 out. So -2, 1/18 is really, really close. I probably can't even get it quite close enough. If you plug -1 in, you get 1/6 out. So 1/6 is again really close, just a little bit higher. You can barely see that that's higher. 0, 1/2, we've already got plotted. That's our y-intercept. If you plug 1 in, you get 3/2, or that's the same as 1.5. So over 1, up 1.5. And 2, if you plug 2 in, you get 4.5. So 2, 4.5. Be right about here. So let's connect those points. I'm going to try and make my curve as close to this axis as I can without touching or going below it. So here's my exponential growth curve. Okay, so that is the last example where we're not dealing with any kind of movements. These next ones we are going to be doing some movements on. So flip your page over. I'm flipping my page over here too. Let's look here. So we need to have you add in your is about statement for this side. So we've got exponential growth again. Is about. This is about graphing functions of the form y equals ab to the x minus h power plus k. This minus h and plus k should look familiar because in Algebra 2a, you did movements like this with absolute value functions, and I think also with quadratic functions. These movements are exactly the same as they were before with those two. So we're going to use this in translations to help us translate our exponential growth functions. And then we're also going to do some real-life applications. These real-life applications we'll do tomorrow in class. So don't be surprised when you're done with the notes and done with the video that you don't have this whole entire part filled in. One thing that you might want to put as a note to remind yourself, if you have a plus h next to your x, then that's going to move your graph left. It's the opposite of the way you would think it does. If you have a minus h, that moves your graph right. So again, the opposite of what you think it does. A plus k moves your graph up, just like you would expect, and a minus k moves your graph down, just like you would expect. So what's next to the x is going to be a horizontal movement. What the k is back here, that's going to be your vertical movement. So the way these, okay, let's look at this first example. And here's actually how we're going to graph them. We're going to graph just the basic function, y equals 2 times 4 to the x. So we're going to graph that one first, and then we're actually going to move it. So then we'll move all the points, this minus 2, that minus 2 next to the x, instead of going left to what you think it should do, we're going to move all the points right 2. And then this minus 3 tells us to move all our points down 3. But let's first graph our basic equation, y equals 2 times 4 to the x power. So if you make a table, and I'm going to put this right up on the side because I don't want to fill in any of those other things yet. I'm going to use -2, -1, 0, 1, and 2, just like I've been using. And you can put this off to the side a little bit more. If I plug -2 into that equation, I get 1/8. If I plug -1 in, I get 1/2. If you plug 0 in, you get 2. If you plug 1 in, you get 8. If you plug 2 in, you get 32. So let's put these on our graph first. So -2, 1/8 would be right about here. Negative 1 1/2 would be right about here. 0 2 would be right about here. And 1/8 is actually going to be off of our graph. Okay, 1 2 3. Be right about up here though. Okay, so this function right here is y equals 2 times 4 to the x power. We want to take and move that. We want to move the whole thing, shift the whole thing right 2 and down 3. So I'm going to get a new color here. And I'm going to take each of these points. I'm going to start here at this point, and I'm going to go right 2, 1, 2, and down 3. 1, 2, 3. So I'm going to end up right about here. I'm going to take this other point. Maybe I'll do it, highlight it. This other point. I'm going to go right 2, 1, 2, and I'm going to go down 3. 1, 2, 3. So my new point ends up being right here. Let's take this next point. We're going to go right 2, 1, 2, and down 3. 1, 2, 3. So our new point's going to end up right there. Okay, and then our last one was up here. We're going to go right 2, 1, 2, and down 3. 1, 2, I think it would be right about there. So come right about here. So here, this is our new curve. Okay. And keeping in mind, now instead of our y-intercept had been this point right here, and we moved it over to this point. So instead of being a y-intercept, we're going to change that name, and we're going to call it our starting point. Because it's no longer a y-intercept, but it is still an important point for us. So our starting point here is going to be the point 2, negative 1. Our domain is still all real numbers. Okay. Our range, so this is a little bit trickier here. Let's look where our range is. And in order to do that, let's look at our asymptote. Our asymptote would have been right here, but it actually moved down 3, just like the whole entire graph. So your asymptote is right here. That's the line y equals negative 3. So that's your asymptote. So you've got to think that all of your y values have to be greater than negative 3. So our range is all real numbers greater than negative 3. To find our transformation, we can still look at our original point here, our y-intercept, and 0, 1 would be right here, so that would be a stretch of 2, but then we also have to include that we went right 2 and down 3. So our transformation, we're going to say a stretch of 2. Then we're also going to include right 2 and down 3. Okay, there's our transformation. So on here, I'm going to make it clear that this is my graph. This green one is my graph. If you got a highlighter or something, you should highlight it. I kind of have a hard time highlighting it on here. I don't quite think I can do that. Let me see if I can try it. So this green one, I can kind of highlight it. This is my answer. So you're going to have two graphs on these, but highlight it, do something, make it look at a different color, put a big arrow, say this one, do something to show that that one's your final answer. So that yellow graph is my final graph for this. I started by doing a basic one and then just did my right 2 and down 3 to find my new graph. So let's look at our next and last this video. We want to graph y equals negative 3 times 2 to the x plus 1 and the whole thing plus 4. So again, we're going to have a movement here, and that x plus 1, looking right there. Okay, that x plus 1. Well, normally you would think moving a positive 1 in the x direction, you go right 1, but remember we have to do the opposite. So that plus 1 is going to tell us to move left 1. And then this plus 4 here, that's going to tell us to move our whole graph up 4. So we've got to keep that in mind. So let's start by graphing our basic. Y equals -3 times 2 to the x. Start by graphing this. I'm going to do it by making a table. It's really good in Algebra 2B if you can get used to doing these without a calculator, because if you go on and take pre-calc, most of the stuff you do in there you do not use a calculator. So if you can come up with all these numbers on your own without a calculator, it will definitely help prepare you. So if you plug a -2 into y equals 3 times -2 to the x power, you get -3/4. If you plug -1 in, you get -1 1/2. Okay, if you plug 0 in, you get -3, and that should be obvious because it's your A. If you plug 1 in, you get -6, and if you plug 2 in, you get -12. Let's go ahead and plot those points. So -2, -3/4 would be right about here. And you should be thinking, hey, that 3 is a negative number. My A is negative, so this is going to be a reflection over the x-axis. -1, -1 1/2 will be right here. 0, -3 would be right here. +1, -6 would be right about here. And the rest is going to be off the graph, so I'm just going to draw my curve in. So this is what this curve will look like. But we've got to remember, we've got to make some translations here. I need to go left 1 and up 4 with this whole entire graph. So in order to do that, in order to find my new points, I'm going to take this point. This is one of my points, -2, -3/4. I'm going to go left 1 and up 4. There's 1, 2, 3, 4. So my point's going to end up right there. So that was, make sure I get this right, right about here. Okay, let's do the same thing with -1, -1 1/2. So I'm going to go left 1 and up 4, 2, 3, 4. So my point's going to end up right there. Okay, let's move this point right here, 0, -3. I'm going to go left 1 and up 4, 1, 2, 3, 4. So my point will end up right here. And then let's move our last point. We'll go left 1 and up 4, 1, 2, 3, 4. So our last point will end up right here at 0, -2. So here's my new graph. Here's my new graph after I've made that movement. Well, let's go back in here and fill in some information. Remember, instead of the y-intercept, we're going to call this our starting point because it's no longer our y-intercept, but it's definitely an important point. So our starting point moved over. It was this one. We went over 1 and up 4, so it moved to the point 1, 1. I'm sorry, -1, 1. So -1, 1 is my starting point. My domain, just like all of these, is all real numbers because I could put any value in for x and I'd get an answer out. My range, well, let's first look and see what happened to our asymptote. Okay, our asymptote was here, but it went up 4. So up 4 would move our asymptote right up here. So our asymptote is now the line y equals 4. So our range then also has to move up. So our range is all real numbers, and this is going to be a 4. But our range, because we've got this reflection over the x-axis, is all real numbers less then 4. Last thing we've got to do here is talk about our transformation. So our transformation, if you start by looking at your parent function right here, well, originally our original parent function started here. So to move to here, that would be a stretch of 4 and a reflection over the x-axis. So we've got to include both of those things along with our movement left and up. So we're going to say this is a we reflected it over the x-axis. It's a stretch of 4. Sorry, not a stretch of 4, a stretch of 3. So it's a stretch of 3. And then we went left 1 and up 4. So that's a good, thorough description of what our movement was. The last thing that we should do here is highlight our actual graph that we know is the right one. So this is the graph that we know is our right one. Make sure you do that when you're making these movements. And that's the end of this video. Remember, if you have any questions, make sure you put stars next to it so in class we can look at those very carefully. Have a great night.